column tract, which is the anterior spinothalamic tract, carries pressure and light touch or crude touch. Light touch is with the cotton, you touch and you can feel the sensation. This is a light touch or a crude touch, right? The posterior white column carry, which is the fasciculus gracilis inclinatus, is responsible for tactile localization, 2-point discrimination, vibratory sense. I'll explain this when I'll discuss the posterior white column. The lateral white column, which contains the lateral spinothalamic tract, which I want to discuss today, that is the main focus on it, will carry the pain and temperature sensation. So this was just a brief overview, which you have already discussed and done in the previous classes. Now today we will start first with the anterior and lateral spinothalamic tracts. The anterior spinothalamic tract is present in anterior white column, and lateral spinothalamic tract is present in the lateral white column. They run very close to each other and have almost the same root, but they carry different sensations. Anterior carries the pressure and light touch, and the receptors for pressure and the light touch or pressure receptors, they're different. They're Meissner's and the Merkel's discs. The Meissner's and the Merkel disc, they are responsible for carrying this in. The lateral spinothalamic tract is responsible for pain and temperature sensation, and this is carried by the receptors, which are the free nerve endings present in this. Example is just a pin prick. If we just take an example that your finger has been pricked, right? The pain will travel through the free nerve endings, or it is pressed, your palm is pressed, a pressure is applied, will be taken by the Meissner's and the Merkel's receptors, and that will travel through anterior spinothalamic tract. So pressure and touch will travel through anterior spinothalamic tract, and if it's a prick, it will travel through the lateral spinothalamic tract. The sensations will be carried from the nerve fibers, spinal nerve, first to the dorsal root ganglia, spinal ganglia, which is the first order neuron, right? And then it reaches the posterior horn, where it relays in the substantia gelatinosa in both the tracts, anterior and spinothalamic tract, whatever the receptors are, whatever the sensation is, their first order neuron is same and the second order neuron is same. It's only the difference in the receptors which make the sensation change. Otherwise, they are traveling in this, and the fibers, of course, they are moving. The lateral spinothalamic tract, that is moving from this posterior horn, the sensory neuron substantia gelatinosa, it will cross over and will move into the opposite white column. I'll just zoom this. The lateral spinothalamic tract, the carrying pain and temperature sensation, the first order neuron in posterior root ganglia, the second order neuron in the posterior horn, where the substantia gelatinosa is there. The fibers, now the second order neuron fibers, they arise here and they cross like this into the lateral white column, right? They are crossing, and there's an oblique crossing. That's an important thing. I won't be able to, probably I had a whiteboard, I would have shown you that they ascend not at the same level, they are ascending obliquely, and as a result, there is a difference of 2 to 3 spinal segments. That's very important. When you will be, just remember at this moment, when we will doing the lesions, then you will get the concept of this oblique region. They are crossing over, they're crossed fibers, and they're moving in the opposite lateral spinothalamic tract, right? So, and then they ascend in the spinal cord in the lateral white column, And likewise, the anterior spinothalamic tract that is carrying the pressure and touch will pass through this posterior root ganglia, which is the first order neuron, will pass into the posterior horn, into the substantia gelatinosa. Its fiber also cross, but they are moving into the anterior column. So the fibers, they are separate fibers and they're moving in separate columns, right? So they will move in the anterior white column as anterior spinothalamic tract, and this will move as the lateral spinal, and both are ascending. Both are ascending and moving like this, and they're very close to each other. And as they ascend through the spinal cord, then they move through the medulla and pons, and then they join together. They don't mix, but they are very close to each other, like that they have joined each other. They see this vertical disposition here. This is the sections or the whole pathway of these tracts, right? This is the spinal cord, the brainstem here, and the cerebrum, right? And they have shown you the whole of this brainstem in the sections. The spinal cord here, the section of spinal cord. Then there's a medulla section here, right? The medulla is shown, the upper part of the medulla and the lower part of the medulla, there is a difference. And then there is a pons, then the midbrain, and then the cerebrum, right? So this is how they are ascending the lateral spinothalamic tract and the anterior spinothalamic tract. इसको मैं थोड़ा सा और zoom कर लूँ और आपको, ताकि मैं इसको ज़रा थोड़ी देर के लिए गायब कर देती हूँ. And I want this diagram to be highlighted more. All right, now you can see here the spinal cord section. This is the side, the receptors were on this side, right? So if the fibers, the pain sensation was that it's your right hand, which or right finger, which was pricked, right? The pain prick will travel through the pain and temperature receptors, and pain and temperature receptors, the free nerve ending, through the sensory part of the spinal nerve, will move into the dorsal root ganglia, which is on the posterior side, which is the first order neuron, will move into the second order neuron here, and the second order neurons, they are present here in the spinal cord, in the posterior horn, and then they cross over obliquely and they're moving into the lateral white column as the lateral spinothalamic tract, passing through medulla, into the medulla, right, into the pons, and into the midbrain, and then into the internal capsule, thalamus and internal capsule, and then into the cerebral cortex. See, they were laterally, and as they are ascending, they have moved towards the central zone, and then the third order neuron fibers, which are mainly in the thalamus. The third order neurons are in the thalamus. This is the ventroposterolateral nucleus of the thalamus, and then the final destination is the sensory cortex, which is the postcentral gyrus. All right. So this is the whole pathway, which is of the lateral spinothalamic tract. Similarly, the anterior spinothalamic tract, which is carrying the touch and pressure, that is also traveling posteriorly and then into the dorsal root ganglia, and from the dorsal root ganglia into the dorsal horn of the gray matter, where they go to the substantia gelatinosa. This is the first order neuron. Substantia gelatinosa is second order neuron. Then they cross over into the anterior gray matter. And they ascend like this in the anterior. And when they reach this part of the pons, they're very close to the lateral spinothalamic tract and join. And together, they are forming a lemniscus. Lemniscus is a broader band, right? They are fusing and they are forming a lemniscus, a sheet, and this is known as spinal lemniscus. In addition to the lateral spinothalamic tract, anterior spinothalamic tract, spinotectal tract also fuse at this level. So the spinal lemniscus is in the pons, which is actually the closed association, or it is the just if you just wrap these three bands in a ribbon, so a lemniscus is created. There's a lateral, there is an anterior, and there's a spinotectal, and this together is known as spinal lemniscus. And then this in this you can see a band here. And you call here the spinal lemniscus. This is the midbrain level. It is passing through the thalamus. This is the thalamus here, thalamus in this section, the thalamus, which is a third order neuron and which is the main nucleus of the thalamus. It's the VPL, the ventroposterolateral nucleus, and then they pass through the internal capsule, and from the internal capsule the fibers radiate, and these fibers are known as corona radiata, which separate out and they reach the final sensory area, which is the postcentral gyrus area 3 to 1. ठीक है जी, ये सारी कहानी जो मैंने भी आपको जुबानी यहाँ इसके ऊपर डायग्राम के ऊपर कराई है, दैट इज रिटन हियर. द pathway of the lateral spinothalamic tract, the first order neurons are in the dorsal root ganglion and the receptors are the free nerve endings, and the fibers they reach the tip of the posterior gray horn. And this is an other important point जो मैंने अभी नहीं बताया था कि when the fibers they reach here in the posterior horn, in this diagram, just watch here. When the fibers reach here, as I said, they will relay in the substantia gelatinosa and then they cross over like this. Now, but some fibers, when they reach the tip here, they are ascending and they descend. They ascend and descend. These ascending and descending fibers, they form another tract which is known as posterolateral tract of Lisieux. This is the posterolateral tract of Lisieux, which is actually forming the connection between all the tracts which are arising at different levels, and they're interconnected also. Did you get this point? That each tract is arising from its spinal nerve. One is rising at this level, the second at this level, the third at this level, the fourth at this. So they need to have a connection between each other, and that is done by this posterolateral tract of Lisieux, which is the fibers which, when it reaches here, they are ascending and descending and the connecting the different segments with each other. So the second order neuron fibers, they are in the substantia gelatinosa, in the posterior gray horn. They cross obliquely within one segment of the spinal cord and ascend in the opposite lateral white column. And within the pons, they are more posteriorly, and they join anterior spinothalamic and spinotectal tract, and together the three are going to form the spinal lemniscus, right? And then they pass through the midbrain as spinal lemniscus, and the region of the midbrain where they are passing is known as the tegmentum. These points are very important because these points can be highlighted in the MCQs. Third order neurons are in the thalamus, and which nucleus of the thalamus? It's the VPL, the ventroposterolateral nucleus, and then they pass through the internal capsule and its posterior limb, and then through the corona radiata into the cerebral cortex, the postcentral gyrus area 3 to 1. And the same is with the anterior spinothalamic tract. The receptors are for the pressure and the crude touch, and the first order neuron is same. Then the posterolateral tract of Lisieux is also formed. The second order neuron is again the substantia gelatinosa. They will cross and move into the anterior white column, and in the pons they will again join to form the spinal lemniscus, which is the same thing. And then the midbrain and the third order neuron into the thalamus, the VPL, then internal capsule, corona radiata, and the cortex. हाँ जी, यहाँ तक कहानी अगर ये सारी पढ़ी